Let's take a closer look. So normally when people say Arduino, they're often talking about one particular thing, which is their most popular development board called the Arduino Uno. This is what we're going to use in this class, and I'm going to talk about that portion now. So let's talk about the Arduino Uno. I'll talk about the revision 3, which is currently the most popular board. So this is about a $20, if you buy from the official Arduino board, this is about a $20 board that contains a microcontroller as well as a bunch of other hardware, which is the other hardware is actually what makes the Arduino really kind of a unique piece of hardware. So let's go through what that hardware is. So a microcontroller runs a computer program, but what does it do? Well, it's all these other pins that allow it to do things. So an Arduino comes with a bunch of different ports that you can plug in wires to. It's got, I don't know, something like 16 plus digital input and output pins that you can control. You can actually specify whether they transmit digital information, so that's like on or off, so like 5 volts or 0 volts, or you can think about that as ones or zeros. So you can control you can control the digital ports to either output signals that are digital or take in signals that are digital. And you can do that at relatively high speeds, up to, I want to say, like something like 16 megahertz in the system, so relatively fast. The other thing that you can do is measure voltages. So measuring a voltage is like if you're on a continuous scale of voltage that goes from some minimum to maximum. That's called an analog input, so analog measurements. And the Arduino Uno has, I guess, 6 ports that convert analog signals into digital signals that the microcontroller can read. So effectively, it can measure voltage. It's got 6 ports to do that, and other versions of boards, typically like the major upgrade, is that you get more of these measurement ports in other boards compared to the R3. Okay, what else can it do? It also has power outputs. So if you are going to measure something, often you also need to power whatever circuit is attached to your Arduino or is going to be connected. So it's got a bunch of ports on it, a bunch of pins that either supply voltage, so there's a 3.3 volt power supply that comes out of it, as well as a 5 volt power supply that comes out of it. There's also ground, so there's a couple of pins that provide the ground for a circuit. Including one that I have currently attached to what I'm calling the power. But anyway, there's a bunch of pins available to supply power to whatever your project is. There's also a USB connection. So this is actually usually how you get your computer program from the software side, like on your computer, into this microcontroller. So you can upload it via the USB connection while you have the Arduino IDE open. This also can provide power, it can provide the 5 volt power input for your Arduino Uno, and this is often how it's used. This is certainly how we're going to use it. Arduinos don't necessarily have to be hooked up to an external computer while you're using them. You can actually provide their power via either a separate port, so the thing on the left is actually a little DC plug that you can put in, or you can provide that externally via a wire, if you want to run it from batteries or something. So you can either power up the board, in one of 3 ways. You can power it up using a DC power supply, using your own USB connection if you're connected to a computer, or using an external set of wires. So, it's a relatively nice, self-contained piece of hardware with both decent processing power and hardware that allows you to control and excite a range of digital and analog circuits. So the digital input and output, in addition to measuring, it can be used to provide a communication channel to external IC circuits. So modern modern integrated circuits often have a communications protocol because they have their own like little things. So like in our class, we'll work initially with a thermocouple, like self-contained IC circuit that contains all the amplification, all the preconditioning, the like unit conversion, the ice point reference, all contained in an IC chip. But the Arduino needs a way to communicate back and forth with that. So like the digital pins can do that. So there's two standard ways to do this. One called SPI, which is I think a serial peripheral interface, which is like a 4-pin method that uses 4 of the digital pins to send and receive information. And then there's one called I2C. I have no idea what I2C stands for, but basically it's a 3-pin method of sending information back and forth to external IC chips. So the Arduino can do all of that in terms of hardware. It just basically needs you to do the computer programming to tell the microcontroller what it's supposed to do. So I'll talk about how you actually do that part next.